All right. Hello, everyone. Welcome. Hope you're having a nice week. Just a quick announcement slash update before we hop into today's topic. Yeah, hopefully you're aware, but just in case you aren't, I finished grading the first in-class assignment. So you should have gotten your grade back on that with some feedback on Canvas. You can take a look on Canvas and see what I had to say about it. And I'm hoping to keep on grading because I know we just had that second assignment in class on Tuesday. Getting sick last week kind of slowed me down, threw me off track a little bit, but I don't like being behind on grading. So I'm going to keep grading and really hoping to get assignment two graded. Honestly, this week would be ideal. So that's what I'm going to try and do. But yeah, if you have any questions or want to talk to me about either of the assignments, I'd be happy to do that with you sometime in my office hours or over email or whatever works best for you. Just wanted to make sure that you're aware that I am getting those through grading all those things and going to do my best to try and keep on top of the grading as the semester goes on. Also, just as a little reminder, 1 week from today is our next in-class assignment. So, they come pretty quick during the first half of the semester. There's five in total, and this will already be our third one. So we're going pretty quickly through them. The next one is a week from today, and it's going to be, focused on what we're talking about today and Thursday. In fact, I'll probably mention a couple times some things that are going to be popping up on the next homework assignment. So, you've got that to look forward to for next week. So let's go ahead and dive right on in. We're going to talk about Git today. A very, very important tool for anyone who's doing professional programming or even unprofessional programming. It's still an important tool, I would say. So important that we, in fact, introduce students to it right on day one of the intro class. They come to WashU, they take computer science, the very first time doing any kind of computer science for a lot of these students. And one of the first things that we introduce them to is Git. Now, what we don't do is give them a whole lot of information about Git, right? I think for especially students in the intro class and maybe even in other classes in your experience, Git is kind of a way to just submit your homework, right? You commit and push. That's the one thing that most people know how to do with Git, right? Is commit and push. And that means you sent it off to the teacher to grade or the TAs to grade or whoever, and then you're done. Which is a very important part of the Git workflow, and I'm going to talk about committing and pushing today. But there is so much more that Git can offer, and I think we kind of do a little bit of a disservice in some ways by not covering more of these important tools that Git can provide to us in more of our classes. So that's one of the things that I'm hoping to kind of start talking to you about today. What else can Git do, especially as it relates to professional software development? What are some of the features that, if you go on to get a job as a programmer, what are you going to be expected to know about Git? It's going to be more than just committing and pushing. There's definitely more that professional software developers do with Git besides just committing and pushing. But we are going to start with committing and pushing. And to keep it from being a total rehash of what I assume many of you have already done in your previous classes, we're going to, of course, do everything on the command line today. So all of the interactions that I do with Git are going to be via the command line. Now, I know in the past, you've probably interacted with Git through VS Code or IntelliJ or Eclipse or whatever you happen to be using to do your work on, and that's fine. I actually use those tools all the time too, and I don't have a problem with using those tools. However, I think it's very necessary and important to also know how to do those things via the command line for, similar reasons that I've talked about in prior classes. We're not always going to have a big fancy window with buttons to click on. Sometimes the command line is our only interface to a device. So knowing how to perform these kinds of operations via the command line is important for that reason alone. I also want to talk about, commit and push in more detail than perhaps you've seen in some of your prior classes. A lot of students, and myself too, actually, I should include, talk about committing and pushing in the same sentence all the time, but they're actually two separate things. They mean two separate things. So I want to talk about that and go into more detail about some of the stuff that maybe you already are aware of, including drawing some diagrams. I think especially with the more advanced features of Git, it really helps have a visual, to help you understand the organization and how all the different pieces fit together. So let's start with the very, 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 very basics. I'm going to go to github.com, and I assume that most of you have a github.com account. As I mentioned, it's one of the first things that we have our students do in the intro class. For today, though, I need a repository to play around with, and I don't want to use one of my actual repositories because I don't want to mess up any of my work. So I'm going to make a new one. I'm going to make a new repository for me to play around with today and show off some of the different things that Git can do, especially on the command line. So on the Git homepage, I just went ahead and clicked the new repository button that's over here on the left-hand side when it eventually loads. So I'm going to go ahead and click the new repository button. I would encourage you actually to follow along with me as best as you can for today. And if you get stuck along the way, that's okay too. There'll definitely be time for me to come around and help you out a little bit later on. The only thing that we absolutely have to do on this screen is give our repository a name. And so, I'll call mine practice repo 26 for 2026. You can call yours whatever you like. Of course, you don't have to call it the same thing as me. There are some other options on this screen that you may or may not end up using as you go along in your programming career. Some of the ones that I've definitely used before are adding a README file. In fact, that's one that we'll probably come back and talk about a little bit when we get to the projects, which again is happening after spring break. So I'll be in project mode. And I also am hoping to talk to you about what a git ignore file is as well. Although I'm probably not going to spend a whole lot of time talking about that today. That'll probably be something that we get to on Tuesday. So, there are some important things that are maybe worth talking about on this page. But for now, I'm just going to type in a name for my practice repo, and I'm going to click Create Repository down here at the bottom to give me a brand new repository to work with as we go through some practice exercises today. And here's the screen that it shows me afterwards. This is an empty repository. There's nothing in it. No files, no nothing. So the repository exists, but it is blank. It is completely empty. And what I've actually done so far is I've created what's called what I usually call the remote or the global repository, or you might hear referred to in a few ways. Remote or global or origin is another word that often is used to refer to this repository. When you hear one of these three words, I want your brain to think github.com. This is the version of the code that exists on github.com. And when we're working on teams, that's important. This is the centralized version that all of the members of my team can see and work with and manipulate. But how do I, as an individual, work with this repository? That's going to get us to our first actual command, our first actual, Git process that we need to do. We need to create what's called a clone. Or you might hear it referred to as the local. So both words I use somewhat interchangeably to refer to a repository, a copy, quite literally a clone. So that clone word is chosen for a reason, right? It's a copy of the repository that does not live in the cloud. It's not online. It's not on github.com, but rather it is on my machine. It is on my computer. Or in the case of these other clones, right? This first one on the left might be my computer, but if there's other people on my team, this is another team member who has their own copy of the repository, and yet another team member who has their own copy of the repository, right? So this is what we would call the distributed micro, where I take one centralized version of the repository. That's the one that lives on GitHub.com. And it is distributed out via cloning to all of the team members, all of the people who actually need to work on this repository, make changes on this repository, and add things to whatever project it is that we're working on in this repository. But how do we do that? How do I actually, make changes and communicate those changes. It's especially important to, at some point in time, make sure that if I make a change on my copy, that those changes make it to the other team members as well, so that they're working with the most up-to-date version of the code and aren't duplicating my work or doing something that could interfere with my work potentially, which is something that can certainly happen when we're working on large teams. So we need a way to communicate between the clone and the remote, and that is where our classic commit and push comes in. So let's go ahead and actually start to do some commands on the command line. The first thing that we need to do is clone the repository. So in order to do that, surprise, surprise, we're going to type git clone. Git commands have two parts. The first part is always going to be git, but just typing git by itself is not enough. There's always going to be a second part of the git command, which is the actual git operation that we're hoping to perform. In this case, we're hoping to perform a clone, and in order to clone a repository, we need the address of that repository, which GitHub gives to us. That's going to be this right here, this address right here. So I'll go ahead and paste that on in. And once we do that, it tells me that it's cloning. It always is going to clone it into a new directory that has the same name as the repository that I'm cloning. So if I run ls, you'll notice that after I clone practice repo 26, I now have a directory called practice repo 26. That is the folder that contains my repository. So I generally will want to cd into that directory. And it told me, and I can verify with ls, that this repository so far is empty. There's nothing in it. There's not anything in it. No files, no code, no nothing. So let's change that. Let's put a file in here and add it to the repository. So I'm going to use Vim to do this. You don't have to use Vim to do this, but if you want to use a different method, that's totally fine with me. I'm going to use Vim to just make a simple text file. We're not going to be dealing with a whole lot of code today. Eventually we will, but for today we're going to keep it simple. Just deal with text. So, okay, I open up a new file in Vim and type in a message. It doesn't really matter what the message is. I'm just going to say hi. I will use :WQ to save that file. And now when I run ls, I see, okay, there it is. It might seem like it's in the repository because it's in the folder that we cloned. However, we need to take an additional step to ensure that the repository is going to be tracking that file. So I'll talk about this in a lot more detail on Tuesday, but not everything that is in this directory needs to actually be part of the repository. In fact, there are certain things that we don't want to include in the repository, that we very much want to avoid putting into the repository. But for the purposes of this exercise, we very much want this file that I just created to be in the repository. And so I want to introduce you to a very important command called git status, which simply tells us, as you might expect, the status of the current repository that we're in. But it's listed under untracked files, meaning that while it is technically in the directory of the repository, I have not told Git that I want it to keep track of that file yet. So I need to tell Git that, hey, I want you to actually track this file for me. I want you to keep an eye on this file and watch any changes that happen to it. And the way that we do that is by using git add. This is a step that you usually don't have to do when you're using VS Code or some other user interface to interact with Git repositories, right? Those files usually get added for you, usually by checking a box or staging them is what you might hear this referred to. But I'll go ahead and add, and we need to be specific about what we're adding. So this would be the command to add this specific file. A lot of times you'll see people run the add command like this with a star. That means add everything. Be careful with that one though. I've already mentioned that there are some things we don't want to be in the repository. So this command can definitely be overkill in some situations and end up adding files to our repository that we may not actually want to be there. In this case, I'll be specific. I'll say git add hello.txt. And now that we've done that, let's run git status again and just check and see how things are looking now. And it says, okay, great. It's no longer in the untracked category. It is aware of this file. It is aware that we care about this file and want it to be included as part of the repository. We're ready to move on to the next step, which is to commit this file. So, as I mentioned before, committing and pushing are two different things. So let's talk about what it actually means to commit something. A commit is simply taking a snapshot of the repository as it exists in a given moment in time. Did you have a question? Yeah, what's that? Yeah, for untracked files, I mean, it's somewhat related to what I'm talking about right now. If a file is untracked and I make a commit, those untracked files will not be included as part of my commit. So it is important that we add them if we do want them to be as part of the commits that we make. Yeah, great question. So yes, a commit is simply a snapshot of our repository at a moment in time. And it's not just a snapshot. I know we only have one file here, right? So the snapshot is only going to contain one file. But in practice, if there's 100 different files, the snapshot is going to contain all of them. It is quite literally a snapshot of the entire repository as it exists at the moment the commit was made. So a commit is quite literally a moment in time. How does this repository look at this particular moment in time? That's all that it is. That's all that it is. It's just telling Git, hey, record everything in the repository as it looks right now. I want you to remember that and call it a commit. So how do we do that? How do we actually tell it to commit via the command line? We're going to use the git commit command. Anytime we're making a commit, however, we have to include a commit message that is required. Again, if you've done this for the intro class, 1301 in VS Code, there's a text box for you to type in what the commit message is, right? We're using the command line, so no such text box exists. So we have to do it using a flag. The -n flag is non-optional when you're running the git commit command. You have to use -m for adding a commit message, and then you have to put a commit message afterwards in quotes. So something like adding hello file or whatever the commit is actually doing. This will be my commit message. Oh, and here we go. I'm actually really glad that this happened. So this is a very common thing that happens when students are using Git, if they have to get a whole lot more coming to this class. This is a new laptop. My old laptop died a little while ago. Had to get a new laptop and reinstall everything. So this is a fresh copy of Git that I've got on here. And so that's why I'm seeing this message. It's saying that it needs to know who I am. So every commit has an author associated with it. Every single commit that gets made has to have an author associated with it. So it's telling me exactly what I need to do to solve this problem. In fact, I'm going to go ahead and solve this right now by copying this first one and pasting it in, and then obviously replacing this with my actual email address. And then I'll go ahead and copy the second one and do a similar thing. Just telling Git who I am, what is my name, and what is my email address, so that when I make this commit, it is essentially signed by me. I am the one who authored this commit. I'm the one who made these changes and told Git that I wanted these changes to be saved, that I wanted them to be tracked. I feel like this is very important. So put yourself in a few different contexts, right? If I'm working in a company a very large project with lots of different people contributing, very, very important to know who's contributing what, especially for your boss's sake, right? You definitely want to be able to go back to your boss and be like, hey, look, I made this commit, this commit, this commit. Here's all the fun stuff. Here's all the nice, cool stuff that I've added to this project. There's direct proof that it was me that added these things. And I think actually AI is making that even more important, right? Because yes, vibe coding is definitely a thing, but regardless of where the code comes from, whether you personally wrote it yourself with your hands on the keyboard, or whether the AI wrote it for you, you still have to put your name on it. And putting your name on it means something, right? It means if AI wrote the code, that at the very least you looked at the code and maybe modified it or tested it or ensured that it does what you need it to do, right? So that authorship, that accountability piece is so, 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 so important. And will definitely be looked at if you're ever a professional developer working on a large team. So now that I've done that, let's try the commit again. The commit didn't work the first time because I didn't have my, information set up. Now that I've done that, I can hit the up arrow a few times to go back to the commit command that I tried, and hopefully this time it'll work. Looks like it did. It tells me that one file has been changed. One line has been written in that file, that tracks with what I actually did. But if I go back and I take a look at, github.com and I refresh the page, you'll notice that nothing has changed here. Nothing has changed here. A commit is simply making a snapshot on this clone, right? On the clone that is on my computer. So the commit, as of right now, only exists here. So how do I take that change then and make sure that it gets to the remote, that centralized version of the repository? That's the other half of what students are used to doing. That is the push. What am I pushing? I am pushing commits. That is what is actually being pushed, is a commit. So the act of pushing is taking whatever commits have been made on my computer, which could be more than one, by the way. It doesn't have to. A lot of times, I think we are only pushing one commit, especially if you're doing it in the context of a homework assignment, right? You get all the way to the end of the homework assignment, you do one commit and push at the very end where it just skips the whole homework assignment. But it doesn't have to be that way. If I make lots of commits, I can push all of those commits at one time with one push command if I want to. And that is something that will happen, right? That is actually a pretty common occurrence. But committing is one act, and pushing takes those commits from my computer and ensures that they make it back to the origin computer. So when you say commit and push, I know we treat it like one operation, but it's actually two separate operations. Let's try doing the push. Now that I've made the commit, we can run git push to try and do the push. And okay, it's asking me for my login information. Maybe it's doing this for you, maybe it's not. It depends, again, kind of on how much you've used the command line to do git stuff in the past before you took this class. If you haven't done a lot of git stuff at all, then I would imagine it's probably asking you for a login, just like it's asking for me. The problem is if I type in my username and my GitHub password, it's going to tell me it doesn't work. And you might be thinking, well, you just typed your password. I assure you I didn't. There's another reason why it doesn't like my username and password. A few years back, GitHub decided that instead of using passwords to authenticate users when they are interacting with repositories, passwords are weak. How many of you reuse your passwords across different things? You're not supposed to do that, right? But we do. I don't have room in my brain to make a different password for every single account that I have. And not only that, but people choose weak passwords all the time. QWERTY123 is a terrible password, right? So it can be easily guessed. And so GitHub said, okay, we're not trusting passwords for code anymore. we're going to make everyone use something called a personal access token. So when it asked me for my password just now, it actually was not asking me for my GitHub password that I use to log into github.com. What I needed to provide right there is something called a personal access token. And this is a step that confuses a whole heck of a lot of people when they first get Git set up. So I kind of want to walk through this process with you now, show you how to make a personal access token. If we do this properly, right, we only need to do this part one time, hopefully, and then we don't have to worry about this ever again. It'll just work for us from here on out. But how do I make that personal access token, and how do I use that personal access token? Let's go back to github.com. And I'm going to click on my profile up here in the corner and go down to the settings option that is here. Once I get to the settings page, I'm going to scroll down, and then on the left-hand side at the very bottom of that menu, I see something that says developer settings. That is where I'm going next. And finally, on this screen, I can see there's something here called a personal access token. There's actually two different kinds of personal access tokens. I'll be honest with you, I have only used the classic kind. I've never used this fine-grained token before. I'm sure there is some reason why they exist. I don't know enough to speak on that, but I do know how to use these classic tokens, and that's what I want to walk you through now. So here is a list, actually, of all the tokens that I currently have. Your list, I'm sure, looks different than mine. But what I need to do is I need to generate a new token. So I'm going to click the button up here in the top and click Classic. Okay, now it actually wants me to enter my actual password. This is my password, not a... This one's not a trick. This one actually wants my GitHub password to proceed. And I'm ready to now create a personal access token. These personal access tokens grant access for one, it's not done on a computer basis, but actually on an application basis. So I'm making one right now for the command line. If I also wanted to use Git through another utility, I think VS Code has an option where you can log in with your username and password, but not all of them do. I know Eclipse, for example, requires a personal access token. If I wanted to do Git operations through Eclipse, I would have to make a separate personal access token for that. I guess you could reuse them, but it's kind of tricky to reuse these for reasons that I'll explain in just a minute. So in the note, I usually say where I plan to use this personal access token. This is my, new laptop command line, right? That's where I plan to use this personal access token, is on the command line of my brand new laptop. All of these have an expiration date, although you can see one of the expiration dates that you're allowed to pick is no expiration. GitHub does not want you to pick this, though. Even though I'm going to, because you can see it says GitHub strongly recommends that you set an expiration date. This is a security thing. If you are working on a program that has strong security implications, then I think picking an expiration date is probably a good idea. But if you're just making it for school or for personal use, I don't think that's necessarily an important thing to have. If you leave the expiration date at 30 days, that means that 30 days from now, I would have to come back and make a new personal access token just to keep using Git on the command line, which is inconvenient, right? The classic trade-off, though, of security. I can make things more secure, but that usually comes at the cost of convenience, and vice versa. I can make things more convenient, but that usually comes at the cost of less security. For this particular case, right, for academic purposes, for personal purposes, I'm not worried too much about the security piece. So I'm going to set it to never expire. And then I'm also going to check this box, the box next to repo. That is going to allow this personal access token to do anything with repositories that we need to do. Committing, pushing, all the other stuff that I'm going to talk about after we get through committing and pushing. These other ones down here, I'm sure have a purpose. I'll be honest once again and say that I've never had a need thus far to use any of these other checkboxes that exist. I'm sure there are reasons, and as you go further in your career, maybe you'll come across a need to use some of them. But for our purposes and for 99% of the classes that you're in, giving it repository access is the only thing that is absolutely essential. And then I'll hit generate token down here. And now this is the actual token. This is the actual personal access token. Again, this is GitHub's way of saying, I don't like humans choosing passwords, so I'm going to force you to use this very long, more secure personal access token as your password. And I think it's also important to note that this personal access token needs to be used right now. It will not show this to me again. If I navigate away from this tab, that personal access token is gone. I cannot access it. So I need to make sure that I use it right now and I get things set up properly right now. Otherwise, I'm going to have to come back and make a new personal access token if I didn't get this one properly set up. One thing that sometimes people will do is copy this into a document, right? So that they can have it for later. Kind of defeats the whole purpose of the personal access token to do it that way. Again, if it's just for personal use, okay, maybe not that big of a deal. But if you're at all worried about security, that is an absolutely terrible thing to do, to write down your personal. It would be equivalent to writing down my password in a document. Anybody who looks at that document can see my password. I'm actually making a big security no-no right now because I'm recording this and I'm going to post it on YouTube afterwards. And, having my personal access token on YouTube, probably a bad idea. So after class, I'm going to go and change it and make a new one so that I don't have to worry about people pretending to be me on github.com, right? That would be not a good thing to have happen. But for now, I'm going to use this one. So I'm going to click the copy button and I'm going to come back down here. And remember, I know this is kind of a long tangent, but the whole reason I set up this personal access token was so that I could hopefully push this commit that I made. So let's try it and do this push again. I'll type in my username. And now this time, instead of typing in my password, I'm going to paste that personal access token in. It's very scary because it does not show it. I hit Control V. I promise you I did, but it doesn't show any indication of that, right? The cursor didn't move. You just kind of have to trust that it got pasted properly and hit return. And you'll know that it worked if you see something like this. It's an indication that it was. So what does that mean that it was successful? Remember, a push takes all of the commits that I have on my local repository and sends them to the remote repository, which is github.com. So if I now go back to the repository page on github.com and find the repository that I made, which is not in my list. That's great. What did I call it? I called it practice repo 26. There it is. If I make my way back to the GitHub page, we'll see that, oh, hey, the file is there now. That's the commit message I wrote right there. That is the commit message I wrote. It happened 12 minutes ago. If I click right here where I see one commit, right, that's me. So that's my authorship. It was able to apply, my name to that commit since I set all that up on the command line. We have successfully pushed our first commit from the command line to github.com. I'm actually not quite done yet, though, because I want to point something else out and talk about another potential issue. Let's pretend that I make some more commits. I know that I haven't, but let's pretend for a second that I make more commits and I want to push them. Okay, I run git push and it's asking me for my username again, and I'll have to put in my personal access token again. That's bad. So I can do that right now because I still have the tab open, right, that shows it to me. So I can copy and paste it in there again if I want to. But imagine if I come back and I try and do some work 2 days from now, right? That tab is long gone. That personal access token is long gone. I need Git to remember that for me. I need Git to remember my personal access token so that I don't have to keep putting it in over, over again. Because I'm not going to have that personal access token forever. So I'm going to back out of that using Control C to get me back to the console and tell Git that the next time I type in my username and password, you need to remember it so that I don't have to keep typing in my username and password. And actually, this is something that I have to Google almost every time I want to do it because I don't remember the command off the top of my head. We're going to use the credential manager. How do I do that? Git remember credentials. There we go. That's what I want. Oh, you can see from where I Googled it up, in the last class. Here's the command that I'm looking for. And I'll put it up on the screen for you all as well. This is the command that tells Git to remember my username and password. I don't have to keep typing them in every single time I perform a Git operation. Now, I will have to do it at least one more time because it hasn't remembered it yet. So in order to make it remember, I'm going to say git push, type in my username, and copy that personal access token for hopefully the last time. Notice that this time there was nothing to push, and so that's Git's way of telling me that. You didn't make any commits. Everything is up to date, so I didn't push it. That's okay. I don't have a problem with that. But just to check and make sure that it worked, if I type git push again, notice that it didn't ask me to type in my username that time. It remembered it for me. It's stored, right? So I never have to worry about personal access tokens again. That's kind of a lie. If my laptop dies and I have to get a new one, well, I'm going to have to make a new personal access token. That's just part of how it works, right? So knowing how to make those personal access tokens is pretty essential if you're planning on using Git. But once you've got it set up on a computer, once you've got it set up on the command line, that's good to go. We don't have to worry about that anymore, at least on this particular machine. Any questions? I want to pause here. Any questions? Anybody have trouble getting the personal access tokens working? Because that's pretty important stuff. I want to make sure everybody's got that part hopefully up and running before we get too much farther ahead. Anybody have any issues with that? Yeah, did you have a question? So that's usually because part of the step is to check that repo box. I wasn't here when you did that step, but usually that's the message that I see when you forget to check that box. So make a new token, make sure that repo box is checked. Hopefully that error message will go away. Common mistake. I've made that mistake plenty of times myself. Anybody else having issues with their? Good. Okay. Not seeing any hands. Seems like most people are doing all right. Great. That is good news. So far, I actually, at least I'm kind of assuming, but hopefully mostly accurate assumption that you've all committed and pushed for, right? So far, I actually haven't shown you any real new Git stuff, just a different way of doing something that you kind of already knew how to do through VS Code or through other means. Now I would like to start talking about some new stuff, some stuff that goes beyond just the typical commit and push. Starting with something relatively simple, relatively easy to understand. I've pushed these materials to the remote, right? But they're still not on these other clones. So I've taken my commits from my computer to the centralized version, but then how do I get them from the centralized version to the other clones so that the other people on my team can see my work, right? They can see it on github.com if they go to the repository page, but they can't add to it from there. If they want to add to it and make additional modifications, they need to get those changes on their computers. So we need an arrow that goes not from the clone to the remote, but from the remote to a clone. So how do I get those changes from the centralized version of the repository to one of the clones? Well, taking commits from my computer to the remote is called a push. Doing the opposite direction from the centralized repository to a clone is called a pull. So making a pull is basically saying, hey, github.com, send me any commits that I don't have from my teammates. Now, this is a little bit hard for me to demonstrate since I only have one computer, right? But we can kind of fake it a little bit, which is what I'm going to do. I'm going to fake it a little bit, and as I do this, this is definitely a situation where I would say don't ever do this in a professional environment. It's a big no-no. I actually kind of hate that you're even allowed to do this on github.com. I think it's yeah, just not a great thing. I'm going to add a new file directly to the repository from github.com. I really don't like this. I think that all files should be added from a clone and pushed to the centralized repo. I really, 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 really do not like creating things directly on the remote repository itself. I think it's very bad practice and can lead to lots of problems, especially if you're working on a big project with lots of different contributors. You can really mess stuff up by doing this. But for the purposes of this example, I'm going to do the bad thing that I'm telling you should never do and just make a quick little file in here, test.txt, and click the button to commit the changes. Because I need something to pull, right? I need to have something to pull. So I just made something that exists on the repository page. I can see that it is here, but if I go back to my local version and I do ls, you can see that I don't have that file, right? So there is now a change. There's now a commit that exists on the centralized repository that does not exist on my own clone, on my own local copy. So how do I get it? Well, we're going to do a pull, and it's as simple as that. Simple as saying git pull. There's really nothing more to it than that. And if everything works properly, this is another situation where likely ask you to log in. So if it's asking you to type in your username and password, that's an indication that you didn't get your credentials stored properly in the last steps. You might want to revisit them. But if everything works properly, here's what we'll see. It tells me that it pulled down this file, test.txt. That's the one that I made, right? And now if I hit ls, I'll see that that file actually exists. And furthermore, I can see that, if I cat that file, it has the contents. So pushing takes commits from my machine, sends them to github.com. Pulling takes commits from github.com and brings them to my machine. And both of those actions are necessary to interact with repositories. Anytime I am working on a repository that I know other people are contributing to, before I make any changes, I'm going to do a git pull to pull down any changes that my teammates might have made so that I know I'm operating from the most recent version of things and not the version from last week that doesn't have all the new stuff in it, right? And same thing for when I'm done. When I'm done doing whatever I'm doing, I'm going to make very sure to commit and push those changes so that my teammates can get them the next time they're at their computers by pulling them, and they're operating with the most up-to-date changes and aren't, adding new stuff when I have all these changes that are on my computer that they can't see or don't know about. So pushing and pulling, very, very important parts of interacting with any Git repository. You're going to be doing these a million times in your career, if not more. These are the very, very basics. I want to talk about something that is more advanced, but before I do, any questions about pushing and pulling? We step it up a notch. Talk about something that I'm pretty certain most of you have not seen or used before, although some of you maybe have in other classes. Let's talk about branching. Branching, I think, is an essential part of what Git provides to us. And it is especially important in, I feel like I'm repeating myself a lot here, but in that situation where I'm working on a big team working with a lot of different people on a single code base, on a single repository. If I'm just working by myself on a personal project, probably not going to worry about branching. It's probably just going to take up more time and effort than it's really worth for me. Not to say that I couldn't use branching if I'm working on a project by myself. It's just not maybe the most necessary thing. But if I'm working on teams, especially large teams, it becomes essential. And the reason why it becomes essential, consider that if I have 40 or 50 people working on the same project, there's going to be lots of changes coming in. And it's very possible that some of the changes that my colleagues are making, my team members are making, are going to run into issues with the changes that I'm trying. So what branching does for us is it tries to provide us some isolation. It's going to isolate the changes that I'm working on from the changes that other people on my team are working on, so that those changes won't conflict, at least not right away. Conflicts are definitely a thing, something that we're going to talk about, an important thing for us to talk about. But branches provide isolation for multiple people working on the same project to try and keep the conflicts from being an ever-present thing that are just constantly getting in the way of stuff. This is also standard practice. If you are a paid developer working on a team, you will be expected to use branching. It's just a fact. It's just a fact of programmer life that branching is a necessary thing that any professional developers will be expected to use. So it can also get a little mind-bendy. So I'm going to draw another diagram actually as I work through these next exercises to illustrate what the branches are and how they actually work. Now, whether you've done any work with branches before or not, you've certainly interacted with a branch because every single Git repository has at least one branch. Every single one. And that branch is called main. So here is my main branch. Every single repository that you've ever interacted with has at least one branch called main. What do the commits look like? The commits, remember, are snapshots. So I usually visualize the commits by drawing little circles, right? Here's the first commit that I made, and here's the second commit that I made. So these are commits. Commit number 1 and commit number 2. All right. So when I make a commit, what I'm really doing is taking a snapshot where you have to do this one at a time. And remembering that on the branch where I currently aim. If you only have one branch, this is pretty simple and straightforward to understand. Every time I make a new commit, just adding a new snapshot to the timeline. And just like you might expect with snapshots on a timeline, I can actually jump back and forth. If I want to go look at some commits from the past, right? I can jump back to them and examine those snapshots and see how the repository looks at a given moment. I'll actually show you how to do exactly that a bit later on today. But right now we're talking about branching. So what does it mean when we create a branch? Well, in the diagram, when we create a branch, it's going to look something like this, where I see, quite literally a branch coming off of the main branch. So branches can't exist in thin air. They have to branch off of an existing branch. So if main is the only branch that you have, then that's where your branch is going to come off of. However, I think it's important to note that I can then further make a branch off of this branch if I wanted to. So I can have branches off of branches. I'm not going to do that today, so I'm going to take that out of my diagram so that it remains accurate to the exercise that I'm walking us through right now. This branch will have a different name, and I can call these branches whatever I want, although there are some rules that I'll talk about certainly in future classes as to when we should make branches and how we should name them and so on. But for now, I'll pick the very unexciting name of new branch for the name of this branch. The way to understand this, what these branches represent and how they work, if any of you are big sci-fi nerds like I am, it's quite literally like alternate timelines in a way, right? And in order to understand what you can see on a branch, you have to. So if I just done anything on the branch yet, if I look backwards, I see commit 1 and commit 2, the same 2 commits that I'm seeing in the branch. So when I create a branch for the first time, the branch looks identical from the branch that I made it off of. In fact, I can show that to you by starting to actually run some git commands to start making branches and manipulate branches. If I want to make that branch that I added in my diagram, we're going to use the checkout command. Outside of committing and pushing, probably the most common git commands that I use, this one is the next most common git command that I use. The checkout command has so many different purposes. So if you want to go home and study up more on Git, I would recommend reading more about the checkout command and all the various things that it can do for you. There's a lot. There's a lot of different things the checkout command can do for you. But in this case, I want to use it to make a new branch. So the way to do that is to pass the -b flag. That's the flag for making a new branch. And then we specify what do we want that branch to be called. And I'll make it match my diagram by calling it new branch. So after I run this command, it not only makes the branch for me, but it also switches me to that branch. I can only be on one branch at a time, but I'm allowed to switch back and forth. Right now, switching back and forth isn't going to have that much of an effect. So when you create a branch for the very first time, the new branch that I created and the old branch that I was on are going to look identical. And I can prove that to you, right? Another good command to know is the log. The log quite literally is just going to show me all of the commits that have been made. And I can see that, okay, I can see 2 commits here. If I want to go back to the main branch, I can check out. There's that checkout command again, right? Git checkout main will take me back to the main branch. And if I run git log from here, oh, look, it's the same 2 commits. Right now, the main branch and the new branch look identical. They are very much identical. But let's change that. Let's make some changes. I'm actually going to go back to my new branch. So git checkout new branch will take me back to my new branch. And I will open up hello.txt and put a new message in here. It doesn't matter what it says, right? Just make a change. Make a change to the file. Any change will do. Save that change. We now want to commit that change to the new branch. So we'll use the same commands that I talked about earlier. I'll say git add hello.txt, git commit -m, and then put a commit message. And actually, this is far enough to illustrate what I'm hoping to illustrate here. If I think about the effect that this has on my diagram, what I've done is I've made a commit on my new branch. But notice, if I'm on this branch, that means this. If I'm on the main branch, I can't. I can see the 2 old ones from back here. But I cannot see this new commit. It's isolated. That's kind of the point. Again, the point is to prevent people from interfering with each other too much. That's why branches exist. That's why we use them. So it's actually a good thing that I can't see that from the main branch. But, I think it's important to really understand what that means. If I check out the main branch again and I examine hello.txt, we'll see that the new message that I wrote isn't there. It's just the old message that I wrote. And if I look at the log, I'll see there's only 2 commits. The 2 old commits are visible from my main branch. But since that other commit, that third commit, was on the new branch, I can't see it from the main branch. I can only see it from my new branch. It's the only place where I can actually see it. So, if I check out the new branch again and run git log, we'll see that there's actually 3 entries here, right? Because this commit, for right now, only exists on the branch. Okay. Well, eventually, I'm going to finish, whatever work it is that I'm doing, and I'm going to want to consolidate these branches again, right? I'm going to want to take the commits that were made on that new branch and make sure they make it onto the main branch so that then anybody who is using the main branch will be able to see the changes that I've made. In order to do that, we need to update our diagram, something like this. This represents a merge. So quite literally taking this branch and merging it back into the main branch. That way, any commits that were made on this new branch will also be visible, will also be accessible from the main branch. And the command to do that is unsurprisingly called a merge command. So you have to merge from the branch that you want to merge into. So in the case of this diagram, right, I'm merging new branch into main, which means that I need to run the merge command from the main branch. So I'm going to first check out the main branch, and then I can run the merge command specifying specifically that I want to merge my new branch into this main branch. And after I run this command, it'll say, okay, I see that there was a change made to hello.txt. If I take a look at the log now, you'll see that, now I see all 3 commits. Not only that, it's showing me an indication that this commit came from that other branch. It's telling me what branch this commit came from. That's kind of handy. It's kind of nice to have, right? So thinking about it again from the diagram point of view, if this branch has been merged in, that actually has the effect of kind of flattening those branches down and making all of 3 of these commits appear on the main branch once again. This is the classic way that new features and bug fixes and things like that are added to projects. Your main branch is the stable branch. Your main branch is the one that people are using, right? The people who are actually using your program are using what is found on main. If I want to add stuff, chances are I'm probably going to break stuff in the progress, right? As I'm adding stuff, or it's just going to take me some time, right, to get everything working exactly right. So I'll do that on a branch. And that way people who are using, the working code on main aren't affected by the changes that I'm making over here on this branch. Once I have made all the changes that I want to, and I'm convinced that they work, right, and that there's not a lot of bugs in them, and I'm ready to allow the world to use those changes, I will then merge the branch with all of those changes into main. That is a deployment. That is quite literally a deployment of new features by merging that branch into the main branch. And you're going to get practice doing this on the projects. That is one of the things that I'm going to enforce on the project is good branching strategy, using lots of branches when you're adding new things to a project. Yes.
So since different languages, different objects make different changes to their reflective, but when they're let's say if they have the same main and they make different like provision on their own, and when they merge, like how does get those like what concepts to update main and what to like
Well, I think you're kind of reading my mind a little bit and one step ahead of me because this is the case where everything goes well. There's no problems. But there are situations in which this can be a more complicated process. So I think one of the things you were kind of alluding to is if there's lots of people working, even if they're on different branches, right? If I have a branch and you have a branch, but we both make changes to the same thing and then try to merge those changes back in, how does Git know whether my change is the one it should keep or whether your change is the one it should, or maybe both, some combination of the two, right? The answer is it doesn't. It does not. Which one is it should? This is a classic case called a conflict. Actually, this is the next thing on my to-do list to talk to you about is conflicts. Conflicts happen. Maybe you've run into a conflict before when using a Git repository. I've definitely seen it happen. And I when I see it happen in class, usually the students' eyes get really big and I can see that it's struck a large amount of fear into their hearts, right? Like, oh my gosh, what did I do? I don't want to deal with a conflict. Um, Hopefully, after taking this class, I want to encourage you, to accept that conflicts are inevitable. Conflicts are going to happen. We can do things to make them less common, and I think we should try to avoid conflicts as much as possible. But anytime you're working on a big project with lots of people making lots of changes, it is inevitable. Conflicts are going to happen. There is going to be two people who make two different changes to the same file. That is a conflict. That is the definition of a conflict. Because now I have two versions of this file. Which one do I want? Your version or mine? Or maybe even more than two, right? We don't have to limit ourselves to just two different versions. It could be lots of different versions of the same file. Which one do I want? How do I reconcile that conflict? Let's do it. Let's make a conflict, and then I will show you how we handle that situation when it inevitably does arise. So in order to pull that off, we already have two branches. I have a main branch. I have new branch. So which branch am I on right now? If you type git branch, it will tell you which branch you're on. So, all right, I'm on the main branch. I'm going to open up hello.txt and I'm going to make some changes to it. I'm just going to type in a bunch of gibberish, right? Doesn't matter. I'm going to then add that and commit it. So that by itself, not going to lead to a conflict. If a file has only been changed on one branch, there's no possibility for a conflict. In order for conflicts to occur, we need to change the same file on multiple branches. So let's switch to the new branch by running checkout new branch. And then I'm going to do the same thing that I just did on the main branch. I'm going to open up hello.txt. Whoops, wrong command. I meant to use vim there. I'm going to open up hello.txt. You can see that gibberish I just typed out is gone. Hopefully that's not surprising because that was on a different branch, right? So hopefully that's not surprising. But I'm going to introduce a different set of gibberish this time, right? Again, it doesn't really matter what it is. I'll add the file and commit. Gibberish round 2. So if we're using our diagram, right, let me illustrate where we are currently. This is what our diagram looks like at this moment in time, where there is shared history between these two branches. That's not what I'm worried about. What I'm worried about is the fact that each have a commit on it. And if those two commits, let me be clear, if those two commits were touching two totally different files, there would be no problems. We would have no issues to worry about. What really makes it a problem is that this commit touched the same file that this commit did. So when I merge them back together, we now have the issue of which one is correct. Is this the right version of the file, or is this the right version of the file? Git will not make that decision for us. But let me make that happen and show you what we need to do to resolve those kinds of situations. I am once again going to go back to my main branch and run the merge, the same merge that I ran just a moment ago. And when I do so, this is exactly what I expected to happen. This is the moment where start panicking. I see that word conflict in all caps. Like, oh, what did I do? I didn't mean for a conflict to happen. I'm just trying to submit my homework or do whatever it is I'm trying to do, and now it's telling me there's a conflict. Don't panic. From now on, I want you to have confidence. Okay, a conflict happened. Let me take a look at it and fix it up. But how? How do we do that? Well, it tells me that there's a conflict in hello.txt. So in order to fix that conflict, I'm going to open it up. Open up hello.txt. And here's what I see. It shows me, so up at the very top, this first line is in common to both, right? So there's no conflict there. That part is actually the same in both versions of the file. But then below that, this was inserted by Git. This is telling me that the branch you're currently on has the file look like this. The other branch that you're trying to merge on, new branch, has a line that looks like this. And I don't know which one you want. And I'm not going to pick for you. So in order to resolve this conflict, that's where you come in. A human being has to step in and resolve this conflict. The computer's not going to do it for us. We have to look at this and make a decision. Do I want to keep the top version? Do I want to keep the bottom version? Do I want to keep them both? Do I want to keep part of one and part of the other? All are acceptable, right? It depends on what the project is trying to do. Imagine that this was code, right? Instead of just random gibberish. So if it was code, very clearly you could imagine the scenario where I want to keep some parts of this code and I want to keep some parts of this code and combine them together and make a one cohesive unit. Regardless of what that answer is, your job is to make it happen. So delete the extra stuff. These are just extra lines. These are just extra formatting lines. So those definitely need to go. And then decide, do I want to keep both of these? Do I want to keep part of one part? There's no wrong answer here. Well, there is a wrong answer here, but the wrong answer depends on the project you're working on. So I can't tell you whether you should keep the first one or the second one. You have to make that decision based on the project that you're working on. So maybe in this case, I'll decide I want to keep both. Okay, that's fine. Keep them both. Save the changes. And then do the same process that I've already done at least a few times today. Add it, commit it, and we are done. The conflict has been resolved. We have resolved that conflict. It is now taken care of. There is now one copy of this file that exists, right? And it might have a little bit of both things in it, but there's still only one version of it now. The conflict is gone, and we can proceed on from there with whatever we need to do next. It's a very, 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 very common thing to have happen. Again, especially if you're working on big teams, lots and lots and lots and lots of people. So don't be afraid of the conflicts. Accept them, that they're going to happen. They're still kind of a pain in the butt. I'm not going to deny it, but they're not that difficult to resolve. So just open up the files that are conflicted, make them look good, whatever that means for that project, and then recommit them. That's how you fix merge conflicts. One other thing that I'll point out, and this is probably the last thing that I'll have time to chat with you about before we wrap things up for the day, is actually a lot of times these merge conflicts, I'm actually not going to deal with them exactly like I did just now because in practice, I'm probably not going to be merging branches on the command line like I showed you how to do. If it's a personal project, then yes. But if I'm working on a team, actually, it's considered a little bit rude or even unprofessional to merge your own branches. Because the whole purpose of having branches and separating people's work, well, it serves a couple of purposes. One is isolation, which I've been talking about, but we also want to give our team a heads up. They're like, hey, I finished this work, and give them a chance to review that work. Give them a chance to take a look at the work that I've done and comment on it before it gets merged into the main branch. So the last thing that I want to show you is, what does that process look like? Because this is another thing that you're going to be expected to use on the project that's coming up. So one final time, I'm just going to make a change to this file and yada, yada, yada. It doesn't matter what the changes are. I'm going to make a quick commit. And different from the past, I actually want to push. So I haven't merged this branch. I haven't merged the changes that I made, and I'm not going to. Instead, I'm going to push them. So what does that mean? Actually, if you go to github.com right now and look at the repository page, you'll notice that the only branch I see here under this dropdown is main. I don't see that new branch that I created. And that's because I haven't pushed that new branch yet. But I would like to. So let me push that new branch. It requires a bit more than just the standard git push command. In fact, if I run this command, I expect to see an error like this. It's saying that if you look more specific here, what am I pushing and where am I pushing it to? It even suggests a command for me, which is, I would say, uh, very much what I would like to do here. If you're pushing a branch, you typically need to specify that I'm pushing it to the origin, which anytime I see that word origin, my brain thinks github.com. That is what origin means 99% of the time. And then what am I pushing? I'm pushing new branch. I'm not pushing main, I'm pushing new branch. So once I push this branch to github.com and we go back to the page, you'll see that it already automatically updated. It says it had recent pushes 2 seconds ago. So instead of me just then going ahead and directly merging that into main, if I'm working in a professional environment, what I'm going to do is I'm going to click this button here to open up what's called a pull request. So a pull request, as its name implies, it's telling my teammates that, hey, I just made some changes and I want you to pull them and look at them and give me feedback on them. This is the peer review. This is where the peer review happens, right? This is where the peers on my team are going to take a look at my code and be like, hey, I think you forgot a step here, or, this looks pretty good, but I think there might be a bug that you need to look at, right? So that's where they're going to have a chance to review my changes and provide feedback on it. And if I'm aware of any problems, I would like to make that known up front as well, right? Like, possibly a bug on line 32 or whatever. I'll make sure my team is aware of that when I open up this pull request so that they can focus in on that and give me more precise feedback on that part if that's something that I need help with. But once you create the pull request, we have a page like this where it shows me all of the commits that are part of this branch. So any commits that I've made on this branch so that people can easily see the changes that I've made. My teammates can come down here and add comments like, I think there's a bug you missed on line 87 or whatever the line is, right? Or maybe they think it looks awesome and they'll say, "Hey, it looks great. I didn't find any problems." That's obviously a good thing. And so these pull requests will stay open for however long it takes for my team to review my work and give me the thumbs up that everything is looking okay. And then when everyone on my team is satisfied, I'll actually merge through the pull request. So the amount of times that I actually run the merge command myself via the command line, very, very infrequently is that how that process works. More frequently, we're going to run the merge through the pull request after my team has a chance to examine my work and provide feedback on it, provide commentary on it. So once your team agrees that everything is working and is ready to go, then you can go ahead and confirm the merge, and GitHub will perform the merge for me on my behalf. And if there are conflicts, because there still can be conflicts at this stage, GitHub will inform me of that as well and give me a chance to fix those conflicts before actually performing the merge. So all of that is still potentially part of the process, depending on, what files have been modified and who else is working on this project. But on the project that I'm going to ask you to start working on after, this is absolutely one of the things that I'm going to expect you to include as part of your workflow so that the other members of your team can, provide that feedback for you. Merging stuff yourself without getting the feedback of your team is a good way to get your boss to call you in your office. Like, hey, stop doing that. That's not a nice thing to do. It's kind of an arrogant thing to do, right? You're basically telling your team, you don't need to look at my stuff. I know it's, which we all make mistakes. I've been coding for, 20 years and I still make lots of mistakes all the time. And I very much appreciate having other people go over my stuff. That's part of the job. So, and part of what I'm hoping to get you used to in this class as well. So, I've covered a lot of ground today. What I didn't do is give you any exercises. I promise you on Tuesday, we're going to have lots of good exercises, some of which require you to work with a partner because I want you to make conflicts and resolve them. So, you have that to look forward to for Tuesday, but that's all I've got for you for today. So enjoy the rest of your day. Have a nice weekend, and I'll see you back here on Tuesday. Thanks, everyone.